welcome back to the show. Welcome back. Let's find the greatest common factor. So, if you want to use prime factorization, you certainly can. You can also use something similar to prime factorization, but you don't even need to break it down to all prime numbers. So, 14 and 21, if you think of any number that goes into them, it'd be like 7. 14 is 7 times 2, 21 is 7 times 3. If they have the 7 in common, you bring it down. Do 2 and 3 have anything in common? No. If we did, then you would bring it down with multiplication. So 7 would be the greatest common factor. If you're looking at 48 and 60, you might be like, oh, 6 goes into both of them. 48 is 6 times 8. 60 is 6 times 10. They have a 6 in common. Bring it down. Do 8 and 10 have anything in common? Yes, 2. So 8 is 2 times 4. 10 is 2 times 5. They have a 2 in common. Bring it down. Multiply it with the 6. Do 4 and 5 have anything in common? No. So we're left with 6 times 2, which is 12. 12 is the largest thing that they have in common. Something else that you can also do is you can subtract the two terms. Like if you did 60 minus 48, you get 12. So anything that's going to go in 60 and 48 would also have to go into 12. So sometimes that'll be easier numbers to work with. 5 and 15. We know that 5 goes into both of them. So we'll bring down a 5. And that's it. Do they both have m? Yeah, they both have at least m to the first power, and they both have at least n to the first power. Last one of these, 63 and 48. Well, let's see what 63 minus 48 is. That's 15. So it would also have to go into 15. 15, I know 5 is a multiple, but 5 doesn't go into these. Also, 3 is a multiple. 3 does go into these. So 63 is 3 times 21. 48 is 3 times 16. They have 3 in common, bring it down. Do 21 and 16 have anything in common? No. So that would be it. Do they both have R's? No. Do they both have S's? No. So 3 would be the greatest common factor. Remember, there's always a greatest common factor, at least one, right? So you can never say none, right? If that's the case, you have to say 1, because everything has a factor of 1. Equivalent fractions are fractions where if you simplified them, they would come out to the same fraction. Or if you turn them into decimals, they would come out to the same decimal. So you can change a fraction however you want. As long as you're multiplying the numerator and denominator by the same number, or dividing the numerator and denominator by the same number, you're good. It keeps it balanced. So if we were writing an equivalent fraction for 4/12, I'm going to take it to the simplifying way, which is get it to the smallest numbers you can. So what goes into 4 and 12? I know they're both even, so I know that 2 goes in there. 2 goes into 4 2 times. 2 goes into 12 6 times. So this would be an equivalent fraction. Now it's not simplified all the way. We can simplify even more. Because these are both even numbers, so 2 goes into 2 1 time. 2 goes into 6 3 times. So all 3 of these would be equivalent fractions. They would all come out to 0.3 repeating, right? You could also go up with it. You could do 4 times 100, as long as you did 12 times 100. So we'd have 400 over 1200. This would also be an equivalent fraction. But all they asked for was 2 of them. And they didn't necessarily say simplify it, but that's kind of where we're going with this. So it's good if we can simplify it to its lowest fraction. So let's try 3 more here. 5/15ths, we need equivalent fractions. Well, I know that 5 goes into both of those. 5 goes into 5 1 time, 5 goes into 15 3 times. And that's the simplified version. Now, if we wanted to go the other way, we can multiply both of these by anything. Let's just multiply them by 10. 10's easy, because you just add a 0. So this would be 50 over 150. There's unlimited answers, infinite answers that you can use for these equivalent fractions, as long as you're multiplying top and bottom by the same number, or dividing by the same number. 10 and 12. They're both even. Cut them in half. Half of 10 is 5, half of 12 is 6. That's the simplified version. Or multiply them both by 10, 100 over 120. Or multiply them both by 7, or 6,000, right? This all works. 14 over 20, they're both even. Let's cut them in half. Half of 14 is 7, half of 20 is 10. That would be the simplified version. Multiply them both by 2, and it becomes 28/40ths. Great. Those are equivalent fractions. You survey your friends about their favorite sandwich and find that 8 out of 12, or 8 over 12, prefer peanut butter. Write this fraction in simplest form. So, you guys know this about peanut butter and jelly. When you are making, just peanut butter. The first step when you're making a peanut butter sandwich is to make sure that you comb your mullet so that it is out of the way of your peanut butter sandwich. Always make sure your mullet is out of the peanut butter. 8 over 12 in simplest form. You're trying to break it down with common factors. So you might be able to find the greatest common factor right away, and that'll save you steps. But let's pretend like you couldn't on this one. 8 and 12, every even number is divisible by 2. So we could divide both of these by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. And here we have a similar situation. Both even numbers, so you can divide them both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 and 3 don't have a common factor except for 1, so it will be simplified all the way. Now, you might be able to know that 4 goes into 8 and 12. 4 goes into 8 2 times, 4 goes into 12 3 times. It gets you the same answer, gets you there a little quicker though. So if you can find the greatest common factor, it'll shave down some time. Remember, keep your mullet out of the peanut butter. Never forget that. 6/8. They're both divisible by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. 3 and 4, no common factors except for 1. 9 and 12 are both multiples of 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. 3 and 4, no common factors except for 1. 28 and 35. 7 goes into both of those. 7 goes into 28 4 times. 7 goes into 35 5 times. 4 and 5, no common factors except for 1. Now we're going to bring in some variables. So on these first couple examples, I'll stretch them out a little bit, and I'll show you what I mean here in a second. And we'll learn a property for when you're dividing with exponents eventually. But if you have the same thing in the numerator and the denominator of a fraction, they will cancel each other out. So imagine if you had 2 times 3 over 4 times 2. Now 2 times 3 is 6, 4 times 2 is 8. This would simplify to 3/4. But if you see something in the numerator and denominator, you can cancel them out. You could cancel out the 2 for the 2, and then look what's left. 3 over 4. What? Same thing can be done with variables. You see it in the numerator and denominator, cancel it out. Here's y to the first, here's y to the first. Those will cancel each other out. So all we're left with is an x in the denominator. You have to put something as a place filler in the numerator if it goes away. So we're going to put a 1. 1 over x. So on b, if we were to stretch this out a little bit, 3 times a times b times b, right? That's 3ab squared. Then we have 12 times a times c. The first thing you probably notice is they both have an a. So we can cancel out the a for the a. Now, the numerator has b's, denominator has c's, so those we can't do anything with. But think of the fraction 3 over 12. What goes into 3 and 12? 3. 3 goes into 3 one time, 3 goes into 12 4 times. So up in the numerator, we have 1 times b, which is just 1b squared, or squared. Denominator, we have 4 times c, which is 4c. And I know that you foresee yourself getting the next 3 correct. I'll wait until the applause dies down at home because that joke, unbelievable. All right, I see a B and a B, cancel them out. I've got AC in the denominator, right? Because it's warm, you need to turn on the AC. 2 jokes in the same video, come on. I need a place filler up top, so we'll put a 1. All right, here I see an M and an M, an M and N. Come on, dude, seriously. I'm looking at you, writers. You're supposed to be writing me better jokes. M and M, seriously? They're not gonna like that joke. You got this. You can do better. All right. Also, the 2 and 6 are both even. So divided by 2. 2 goes into 2 once. Yep. 2 goes into 6 3 times. So the numerator we have 1n, which is just n. Denominator we just have 3. So n over 3. And then this one, let's stretch this one out. 24 times x times y over 8 times x times y. I see they both have y's. We'll get rid of those. I see they both have nx. They both have one of the x's. And then 24 and 8 are both divisible by 8. So 8 goes into 8 one time, 8 goes into 24 3 times. So up top in the numerator, we have 3 times x, 3x. The denominator is 1. You don't need to write over 1. If you need a place filler up top, you need to put the 1. But in the denominator, you don't write a place filler. So 3x over 1 is just 3x, right? Because 3x divided by 1 wouldn't change. So that's it for simplifying fractions today.